Okay, guys. So if we were in class, my question would be, what is different about this problem? We have the same word right here in the directions. It says solve. We have a quadratic, so that's all the same. There's a 0 over here, but this is what's different. We're now solving an inequality rather than an equal sign. And just like every other time we've run into inequalities with lines and absolute values and everything, it works pretty much the same way an equal sign does. The only difference is we're going to have a little bit of graphing to do at the end. So we're going to set this up just like it was an equal sign. The first question or the first notice should be A does not equal 1. The second notice should be that there is no GCF. So since there is no GCF and A does not equal 1, what does that mean? We have to use the AC method. Okay, so using the AC method, multiply A and C together. That's going to make it be minus 20. Now we're ready to factor. So I need factors of negative 20. 20 doesn't have too many factors. What? 1 and 20, 2 and 10, 4 and 5. Remember, though, I'm needing a negative 20, so one of these numbers has to be negative. Which one? Let's go over here and look for our clue. This is a plus sign, so that means the bigger of each one of these pairs needs to be plus. So minus, minus, minus. We're looking for these factors to combine together to give me a 1. These combine to give me 19, so they're not it. These two combine to give me 8, so they're not it. These two combine together to give me 1. So there's my pair. Those two numbers go in the binomials. Remember, this is the AC method, though, so now we've got to undo that multiplication. We multiplied up here by 2 to get the 20, so now we have to divide these things by 2. Okay, simplify, divide if you can. 4 divided by 2 is 2. This doesn't simplify, doesn't divide evenly, so what do? Swing the 2 up in front. Okay, now here's where it gets a little bit different because of the inequality. Because of the inequality, we're now going to use the zero product property, but we're actually going to set each one of these equal to 0. Because what I'm interested in doing right now is actually finding those x-intercepts. I'm wanting to find where this parabola is going to be crossing the x-axis. So since I'm finding the 0, I have it set equal to 0. Solve each one of these. I'm sorry, I didn't show my steps. Let me go back. Okay, minus 5, minus 5. 2x is equal to negative 5 divided by 2. X is equal to negative 5 halves. Okay, so now for the connection of the algebra and the graph. Okay. So we know that this parabola is going to be crossing the x-axis at 2 places. It's going to be crossing it at 2, and it's going to be crossing it at negative 5 over 2. Now, think about where negative 5 over 2 is. If you need to, change it to a decimal. I think that's negative 2.5. So if we have this is negative 2, and this is negative 3, then 2.5 is going to be right there in the middle. Okay, so here's our 2 x-intercepts. Right there and right there. Back in Algebra 1, we learned to decide how the parabola was opening, whether it was opening up or down. Opening up looks like this. Opening down looks like this. Okay, so because this value of A is positive, we know that our parabola is opening up. So that means if this is where it's crossing, by the way, this is the x-axis. If it's It's doing something like this. Okay, it's not very pretty, but that's okay. We don't have a y value. We don't have a y-axis on here, so I don't really know how far down that's going, but I do know that it's crossing the x-axis at those two places, and this is opening up. With this picture right here, you can now answer this question, because this is asking us, where is the parabola less than or equal to 0? The x-axis is where our y values are 0. So what another way to think of this is they're asking us, where is this parabola below, because it says less than, below the x-axis? Well, we can see this is where it's below the x-axis. So the shading that would take place would be these x values. The x values that happen along the number line right here are where our graph is below the x-axis. So our answer, the answer to our question, would be the inequality statement that says x has got to be a number between. Now understand why I'm putting the bars underneath them, because this one up here had a bar. The x values between these two endpoints, and my two endpoints were the answers to, or were my zeros, where they were actually where they crossed the x-axis. So this is the answer to my question. There is a different approach to figuring out what the answer is. And in the next video, I'm going to share with you a different approach. It's not graphical, it's numerical. And Springboard uses that as their example. So I'm going to go over their example and try to help you understand. I'm not going to care whether you choose to do the graphical representation to figure out what the answer is, or whether you do the numerical representation to figure out what the answer is. As long as you can give me the answer to this question, for what x values will this parabola be less than or equal to 0? I don't care how you do it. I just need you to be able to do it. So method number 1, I will show you method number 2 on the next video, and then I will work a few examples for you.